So here's a slightly more challenging long division problem. What we notice up here is that our terms are in slightly different order. They're not in descending order. And another thing you might notice is there's no x squared term. So what do we do in a situation like this? Well, I'm going to need to write this in descending order, standard form, highest degree to lowest degree. And when we get to the x squared term where that would normally be, we're going to put a 0x squared in its place. So anytime we have a missing term, put a 0 as the coefficient. So if we're missing the x term, we have 0x. If we're missing the x cubed term, we put 0x cubed. Anytime we're missing a term in between, make sure you put a 0 as the coefficient. Because if you don't, everything's going to get messed up when you're trying to combine like terms, when you're drawing the line, changing the sign, all that. It's going to get messed up. You're going to make mistakes. So it's best to put a 0 in its place. And this will also be the case when we learn synthetic division. So now we can go about our problem as normal. So what times x is going to give me x to the fourth? Well, I know that x cubed times x gives me x to the fourth. So put an x cubed up there. And now I'm going to multiply down to both of these. So x cubed times x gives me x to the fourth. X cubed times negative 2 gives me negative 2x cubed. And now I'm going to subtract those from the upper two. So I'm going to draw my line, change the sign. Nice little rhyme. Ooh, I can't stop. All right, so 2x cubed plus 2x cubed gives me 4x cubed. And remember, these two are always going to cancel. So just double check that. Okay, yeah, they cancel. I did it right. If they don't cancel, you did something wrong. Next thing we want to do, let's bring down that 0x squared. See, in this case, we would have been bringing down the negative 3x, and that would be incorrect. You've got to bring down the next term. So we had to put something in its place since it wasn't there originally. Now we're looking at our 4x cubed and our x here. So x times what would give me 4x cubed? Well, it would be 4x squared. And now I'm going to multiply down this guy to both of these. So I have 4x cubed, and then 4x times negative 2 gives me negative 8x squared. Draw my line, change the sign, and I, of course, once again, have these two canceling out, and then I'm left with the 8x squared, because 0x squared plus 8x squared gives me 8x squared. Let's bring down our negative 3x. And once again, we're going to look at this term here and my one out front here. See how we kind of move our way down. We go from this term to this term to this term, and it just repeats over and over, the same 4 steps over and over. So what times x gives me 8x squared? Well, that's 8x. Now I'm going to multiply this 8x to both of these terms here. So 8x times x gives me 8x squared. 8x times negative 2 gives me negative 16x. It's a long problem here. Draw the line, change the sign. Of course, these two cancel because they always will. And I'm left with 13x. Last time bringing a number down, it's the last one, so minus 6. Well, what times x is going to give me 13x? 13, of course. 13 times both of these here, I'm going to get 13x. And 13 times negative 2 gives me negative 26. Draw my line, change the sign, so that becomes positive right there. And I am ending up with a positive 20. Well, I got 20 left over, so my answer is going to be x cubed plus 4x squared plus 8x plus 13. And since it's positive 20 down here, I'm going to have plus 20. And what am I dividing by? X minus 2. There's my final answer. So it's all this mess up here, this mumbo jumbo, plus my remainder divided by what I was dividing by. Bippity bop, just don't stop. That's about the longest problem that you'll have when you have 5 terms to deal with. Whew! If you can handle this, you can handle anything.